Alright, so today we're going to talk about polygons. And polygons, the definition of it is a closed figure formed by three or more line segments that we call the sides. Okay? So it's got to be three or more line segments connecting together, closing a figure in. Okay? The sum of the measures of the interior angles of any polygon can be determined by the number of triangles that can be drawn within the polygon. So let's go ahead and complete this table below. First, notice in a triangle you have three sides. Okay. Okay. And inside this triangle you got one triangle. There's one triangle. Okay. And we already know triangles add up to 180 degrees. Okay. For a quadrilateral, that's a four-sided figure. And you can see here you got two triangles. And then the inside figures, if you know 90 plus 90 times 4, right? 360 degrees, right? Then in here you got five-sided figure for a pentagon. You can see there's 1, 2, 3 triangles. Okay. And so that those angles add up to 540 degrees. In a hexagon, you got 6. It's 1, 2, 3, 4. And that's 720 degrees. And then you got 7, 5, 8, 6, 9, and 7, and 10, and 8. Right? You can start doing the math here over on the right hand side. So you would have 900 degrees here, okay, 1080 here, okay, 1260 here, 1440 here, okay, and there's a theme that you can see that goes along with this, okay, and it comes with, and the formula is the sum of the interior angles, S, is going to take the number of sides and subtract 2 because that will determine how many triangles you have inside that figure, and then you're going to multiply it by 180. Let's go ahead and do the math here for a few examples. Okay, so 15 gone. If we do this, right, here's my formula, n minus 2 times 180. Well, n in this case would be 15. So 15 minus 2, you got to do that first. So that gives you 13. Times that by 180. And then 15 and a 15 gone, the interior angles add up to 2,340 degrees. Okay, and a 21 gone, same thing. It'd be 21 minus 2 times 180. So 19 times 180. Excuse me. 3,440 degrees. 420 degrees. And then for the next one, right, you got 48 minus 2. It's going to give you 46 times 180. Gives you 8,280 degrees. And then for a 36 again, same thing. 36 minus 2 gives you the number of triangles inside that figure. It should be 34. And then 34 times 180. You get 6,120 degrees is what all the interior angles inside that figure would add up to. Now, sometimes we have this concept called a regular polygon. And a regular polygon is a polygon where all the sides and the angles are congruent. And because all the sides and angles are congruent, we can figure out what each individual angle inside that figure adds up to by taking the sum of all the interior angles, which is that formula. Okay, so S. So that would be my n minus 2 formula times 180. If we take that formula and divide it by the number of sides, we can figure out what each individual angle adds up to. So let's take a look. So a pentagon first. Pentagon, you gotta know the number of sides. That's 5. So that means that if I do that, it would be 5 minus 2 times 180 divided by 5. Well, 5 minus 2 is going to be 3 times 180 divided by 5. 3 times 180 gives you 540. And then you're going to divide that by the number of sides, which is 5, to get each angle inside that pentagon is 108 degrees. Now, you can only do this when they're regular. Okay, so regular. And same thing for the next one, right? So it would be 18 minus 2 times 180 all over the number of sides of 18. Well, 18 minus 2 is 16 times 180 over 18. 16 times 180 gives me 2,880. Divide that by 18. You get 160. So each one of the angles inside that figure is 160 degrees. All right, so now let's take a look at exterior angles. So exterior angles are supplementary to their angles that are adjacent to them. Okay, basically, if you extend out each one of these, they may form a linear pair. You have a linear pair here, you have a linear pair here, you have a linear pair here. Remember, linear pairs add up to 180, so that all you have to do to figure out each one of those angles, right, would be 180 minus 79 to give you 101. So that's 101 there. 180 minus 40 would be 140. And then 180 minus 61 would give you 119. Now, if we added all those numbers up, 119 plus 101 plus 140, you get 360 degrees. Let's take a look at quadrilateral. All right, same idea. So do 180 minus 124. You get 56 for this angle right here. And 180 minus 76, you get 104. And 180 minus 89, you get 91 here. And 180 minus 71, you get 109 here. Now let's go ahead and add those up. 109 plus 56 plus 104 plus 91, you get 360 degrees. All right, let's do another one. So 180 for the pentagon minus 98 gives me 82 here. 180 minus 121 gives me 59 here. 180 minus 87 gives me 93 here. 180 minus 130 gives me 50 here. And 180 minus 104 gives me 76 here. So 76 plus 82 plus 59 plus 93 plus 50 gives me 360 degrees. Let's do the hexagon, last one. So 180 minus 129 gives me 51 in here. 180 minus 124 gives me 56 here. 180 minus 112 gives me 68 here. 180 minus 123 gives me 57 in here. 180 minus 117 gives me 63 in here. And then 180 minus 115 gives me 65 in here. And now let's add them all up and see what we get. 68. You you get 360 degrees. So what are you noticing? A theme here. The sum of the exterior angles of all polygons is 360 degrees, no matter what. So let's do some examples. It says, what is the measure of each exterior angle of a regular hexagon? Well, if I know that the sum of them add up to 360, we're going to divide that by the number of sides. The hexagon has 6 sides. So that means that each one is going to equal 60 degrees. So what is the measure of each angle of a regular 24gon, each exterior angle? So again, the exterior angles are 360 degrees around. We're going to divide that by the number of sides, which is 24. Means each exterior angle is 15 degrees. It says if the exterior angle of a regular polygon measures 112 degrees, how many sides does the polygon have? So what we know here, we know that 360 divided by the number of sides gives us that 12 degrees, right? Well, then that means we're going to have to multiply by n on both sides. So you get 360 equals 12n. And then we're going to divide by 12. And we get n to be 30. So that means there are 30 sides in that figure. Same thing, if the exterior angle of each polygon is 40 degrees, how many sides does it have? So 360 divided by n equals 40. So again, multiply by that n on both sides. 360 equals 40n. Divided by 40. And you get n to be equal to 9. 9 sides in that figure. All right, so that's all I have. Go ahead and work on your math Excel.